The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Tuesday, December 6th, 2022. Maunaloa is in its 9th day of eruption, Dane, and what we're seeing is a few changes on the upslope channels. The Flowfront's still pushing forward, slightly faster in the last few days, but still relatively slowly. It's still inching along, creeping along. Still getting closer to the DKI, Daniel K. Inouye Highway, Saddle Road. And otherwise, we've been keeping an eye on Kilauea too. That's been crusting over here in the last day or so. What have you been noticing? Oh, let's hear ya. Can't hear ya.
Oh, there we go. Yeah, we've had some interesting changes over the last 24 hours. Nothing really big on Mauna Loa, but really the story's been about the weather and how poor it's been. It's like zero visibility. Posted a photo on Tracker a little bit ago, or one was posted, and it's just at the visitor or the viewing area, the traffic hazard mitigation zone, as it's being called, or route, anyways. That area, and it's just whiteout conditions in there from the clouds just setting in and the fog and everything. So really viewing has been pretty poor since we came to you last.
Yeah, in fact, yeah, I've got a little time-lapse playing on a screen here between us, and we had to pull out a whole bunch of obscured views to even see this little bit of what we actually did see. So we can turn to that and talk about this diversion of the channel that's playing here that we talked about a little bit yesterday, and we can see how it's playing out here today. Anything else?
Yeah, that seems kind of like the story right now is about that diversion and the implications of that.
Yeah, for sure. Yeah, so we'll check that out in a little detail. We have some thermal maps to dig into a little bit, and a bit of all the usual stuff. Right? Anything else before we jump into it?
I think that's it for now. I'll jump back in later. If anybody has questions, we will be collecting those, and we'll try and get to a question and answer segment a little later.
Yeah, for sure. Yeah, and let Dane know if you have any issues with our audio or video, and you will also be leading the discussion on the chat. Mahalo, Dane. All right, so starting off with what we mentioned yesterday and we're following up on today, here's that zoomed-in view for the past 2 nights, just the breaks between the weather. So you kind of see the animation jump halfway through there, and that's because we have a whole bunch of daytime and bad weather obscured views missing from in there. But it gives you the general idea of what's happened in the last couple nights. And this is what we mentioned yesterday, as we noticed in this area right up here at this corner bend, that spillover occurring and beginning to flow down the hill. And at the end of yesterday's broadcast, we peeked into the camera and it looked like it had rejoined and had possibly returned to that same channel. But comparing the previous night and last night side by side, it's very clear that that original route of the channel that used to be more this way, right there, has been abandoned, and there's a new path that comes down the hill in this direction over here. And I thought it was interesting that this channel, where this flow is forming a channel, it comes down here and it actually tries to, it's heading right for this main channel right in that area, but it appears to deflect off of the levees that this channel is built. And so instead of rejoining it here, it's actually bouncing off and continuing to flow downhill in that direction. Probably right next to it, side by side. So it's going to go to that same area. It's not going to go anywhere different. There's no reason for alarm or extra concern from that. In fact, what this is doing is it's taking all the lava that was previously flowing down this branch and going this way, and that was going towards a lava flow front. All that lava is now being diverted out of the channel, right? So it's not quite clear exactly what percentage that is, but it's some amount of it, obviously. Some part of it's not going towards the flow front, so it's less lava feeding the front, which also helps it ultimately slow down. That's the way that flow ultimately ends, is when it stops being fed lava, right, for one reason or another. So that's one way it can happen, is by these branches occurring and rediverting and making other small flows that essentially split that whole volume among multiple places. That's one of them that's really noticeable. There's another one actually that comes off of this upper branch right here, and it heads off in this direction. It seems like it flows out, and it seems to stall out or crust over, but it seems to want to keep taking that pathway, and it's spilling back over. You can see it spills over, go back this direction, which means there's some kind of blockage occurring, likely right in here. And so there's a blockage in there. We've noticed a blockage right over here, and there could be others that we're not seeing as clearly in this animation because of so many clouds flying by. That just goes to show how the lava is actually splitting out of the channel, and every time it does that, that's less lava making it to the flow front. And ultimately, that's gonna be what robs that flow of its forward momentum. So if I zoom it out, or maybe I can zoom in further to this downhill section, right? This is also covered by clouds, but you can see the relative jump from the one night to the next night, how that flow is advancing. There's night 1 right there, and there's night 2 slightly below. Keep it like this so you can see animate. You see it advances a bit here. And at the latest report from Hawaiʻi County, it's within about 1.5 miles of the road. And so let's look in at what else is going on. Let's look at the live stream from the UH 2.2 meter camera. So what you can see here is this is a live view. And there's a layer of clouds socked in there in a saddle. But actually, at the summit of Mauna Kea, you're getting a good view of the upper part of this eruption, the actual fissure itself, and the upper part of that braided stream, where it actually forks, but not quite to where it comes back together, is what's visible above the clouds there. So that is that current view, and if we switch to the USGS camera, there it is. Lava is still coming out robustly, right? You can see one way that in 2018 we roughly compared, Dane, the height of the fountains is relative to the height of the cone around them, right? So the cone is obviously growing and changing shape a little bit, But if the fountain is higher than the cone, you can say, okay, it's still pretty good, pretty robust there. And then once it gets about the same height or stops exceeding the height of the cone, then you know that the volume has gone down a bit and the effusion rate is slowed a bit, if all that makes sense. So that's the live look in there. Did want to, while we're looking at that live camera, pull up a couple of the photographs from USGS. This is released on the 4th, or I'm not sure when it was released, but it's from the 4th, and showing that upslope view of that closed-in cone now, and how tall it's gotten, the fountains within. So it's nice to see that slightly different aerial view there. And the caption here, to remind you guys, this fissure is at an elevation of 11,500 feet. That's 3,510 meters above sea level. And the cone around the fissure has been measured at 92 to 95 feet, 28 to 29 meters tall. They do note that there's a temporary flight restriction. So it does seem that some of these images we're getting are from drones that the USGS is permitted to fly up there for the scientific research. So that's one way they can do the measurements. That's one image there, and there's one more I wanted to pull up while we're talking about the fountain. And there's another view of it there. Shows you the length of that cone, right? We saw it from another angle, and it's not that wide compared to how long it is, and that's typical of these cones on the northeast rift that send these big rivers down the north flank here. So in the caption here, fountain heights of 130 feet, 40 meters, with bursts over 330 feet, 100 meters, were measured by the HVO field crews. So that's the highest measurement we have reported so far, 330 feet, 100 meters. Obviously, it's variable, and just measuring when they can. So previous eruptions of this area have had fountains roughly into 400-foot range. So we're in that ballpark right there, 330 feet, reported by the USGS for the fountain height here. So that's just the visuals of the fountain. Let's look at the updates issued by the USGS. We had one this morning at 8:32 a.m. And as usual, I'll try to highlight the differences between daily updates rather than read the entire thing to you guys. So it's still on relatively flat ground and slowing significantly over the past days. So here's a new paragraph. As of 5 a.m. today, December 6th, the flow front was about 1.93 miles, 3.1 kilometers from the DKI, Saddle Road. There continued to be several small overflows from the main channels recorded over the past day and a brief surge at the flow front yesterday morning. During the past 24 hours, lava flow advanced at an average rate of about 68 feet per hour, 21 meters per hour, and that's about twice the rate for the past several days. Over shorter periods, the advance rate varied from 62 to 90 feet per hour. So as much as 90 feet per hour, that's the same as 27 yards or 27 meters per hour, more or less there. Right, the low end being 18, 19 per hour, 62 feet per hour. They continue to say advance rates may be highly variable over the coming days and weeks. Over flat grounds, lava flows advance more slowly, spread out and inflate, and individual lobes may advance quickly then stall. Additional breakouts may occur if lava channels get blocked upslope. This is what we're seeing already. There are many variables at play, and both the direction and timing of flow advances are expected to change over periods of hours to days, making it difficult to estimate when or if, still, the flow will impact the highway. That's the major changes in that first paragraph. This is worth restating now that we have the flow continuing to get closer to the highway there. SO2 rates, still the same reported measurement from yesterday, from the day before, so that nothing new there. And further on, nothing new there as well either. The report from just a few hours ago, a couple hours ago now, 4:36 p.m. today, they are essentially repeating everything with a caveat that they have not made any observations of the eruption since this morning due to weather obscuring views and preventing field work. So that is an issue for everybody, not just the tourists, even the scientists having a hard time seeing anything and observing anything, getting any work done with this kind of weather. So that's the most recent USGS measurement, 1.93 miles, and everything else is the same there. If we turn to the county, well, first let's look at the USGS map. There is a USGS map from today, 5 a.m. And if I zoom in over here, you'll see that's the flow front and how much it's advanced. since yesterday. It's still fanning out, moving forward as well, but also splaying out laterally too. Interesting, there's a second point of growth over here on this other branch, right? So once again, the flow is starting to branch a little bit as it's on that flat ground. Maybe it's not going fast enough to accommodate all the lava that's being fed into it from upslope. So it's starting to back up and spill over and split. So that's something that can occur as well. Right? And that's something that, once again, will prevent or will slow the advance of that particular lobe going forward, and something we expect as eruption goes on into further days ahead. So that's the big picture there. The county map has a 3 p.m. timestamp for today, so a little bit more recent. And they say, let's zoom this in, Flowfront is approaching 1.5 miles from the highway, and that's where that number comes from, is from the county. Highway remains open in both directions, no communities at risk. All areas adjacent to the highway, Old Saddle Road, and near the lava flow are closed and prohibited from safe access to the public for your safety. They do stay in the designated hazard zones, and also noting the weather here, weather forecast for today calls for thunderstorms for the interior areas of Hawaii Island. Fog and rain will make driving hazardous. So the driving conditions are challenging already with the traffic up there, so this is just something else to keep in mind, the weather forecast there. Zooming into the flow here, there is that flow front, and you can see that one edge of it has crossed back across the Hakuloa training area back onto the state land, but it's still kind of sprawling across a boundary there and spreading in all directions from there, including continuing into the training area there. So that is the most recent map. We do have some thermal maps. Here's the most recent thermal map that was captured on December 5th. These are taking helicopter overflights, and they're scanning it all with a thermal camera and then compiling these maps from that. So that's really cool. If I can zoom it in here, there's our Fisher 3. There is that initial channel going downhill. You see it splits up here. There's one braid that's a very high upper one. It wants to split again, and there's a flow that's moving off here. This is, remember, north, and this is to the east, which if you're looking at the mountain from the saddle is on the left side. So there's a flow over here that's coming down. It seems to be more of an flow, the way that it's appearing in a thermal image. There's a braid that's developing here. It's not going very fast. It's not taking a whole lot of lava, but it goes to show that if there's a constriction, there's a spillover point occurring there. Then this braid continues. It splits again down here, right? And of that split, the eastern left-hand side of the mountain splits again. And you can see many of these splits are also having their own little overflows. This is the one that I talked about coming across the mountain that was maybe stalling up, trying to go back together. And the one big overflow we talked about and showed the video of at the beginning, this was the morning it was captured. That's that flow right there. There is a channel that it has abandoned. And that flow now is likely moving something in this direction like this. Like that. So if we can get clear weather to get another image, next time we see one, it might show something along those lines. But this is showing you that complexity of the channel structure. And there is a Maunaloa Observatory Road. So when you look up at the mountain and you see that split of the lava channel and it comes around and back together, more or less halfway in the middle of that is where the Maunaloa Road is getting cut from there, right? And so that's about the source of that spillover breakover point. And it's also where this middle in between the two branches in that island zone flow is also headed. And that, in case you're trying to put things in some perspective, the mountain is so big, so few landmarks, and that big branch of the lava river is pretty easy to see nowadays, the most identifiable part of it. And to put things in perspective, that's that Maunaloa Observatory Road. It goes right across the middle there. So that's just the one image there. Like maybe continue down the slope here. Everything at this point, this flow had branched off, so we really have just this main channel, and it stays coherent all the way up. You can see all the way a single channel that when we approach the flow front shows less heat as it's becoming more distributed. You see it's really fanning out. There's that kind of feather-like shape right there where it's fanning out. So interesting to see those details. And further, they've been compiling these different views of the flows over time. So you can see this was what we just looked at, December 5th, but the whole evolution of the pattern all the way back. So one thing that I found interesting, let's look at, for example, that little split area, right? There's a few areas to look at. The upper braid is in here, and then that large middle braid is right here. So it starts off, you see as two different flows. They seem to bump into each other, but it actually diverge. It's two separate flows right there. And then moving up, it looks like they come back together at the top, but we still see in a thermal image two separate channels there moving downhill. And all the way until right about in here do they finally join as a single flow, and just uphill from the front. So that's how it was on November 30th. The next day, there it is splitting across again. We actually see the difference there. This is like a spot the difference game, but there's one diversion there on that eastern branch, I'm sorry, left-hand side. And you see still two different channels, almost three side by side, as this one braids down here, going to the north. So they stay together, stay separate, and they finally come together right in there. So advancing one more frame, still see that separate channels all the way down. They finally do join once again in there. If I zoom it out, there is that point right there. That was December 2nd. By the 5th is where they're a single channel. So interesting to see how these things don't necessarily fuse back together, but they can actually be side by side, and it takes a while of them actually moving downhill together to then integrate and join and become the same flow. And I go through all this only because we just know now that we have this other flow coming down. It's probably going to do the same thing. It's going to make the secondary pathway next to the first one once again. So that's what we're looking at, and some interesting changes appear in the upper flow field. I'll just scan through. There's from the 29th or the 30th, and then the 1st, and then the 2nd. And you see a lot more complexity developing through here. And then there it is, finally, that abandoned braid feeding a new flow. So that's where the most change is happening, is up in this middle part, and ultimately that affects what comes down to the front, and that's why we're looking in that detail. Here's another way to look at this. This is the USGS maps, with red showing the new flows in each day, and Dana's compiled this into a little animation for us. Mahalo, Dane. So let me zoom it in here to the flow area a little more. And some of this is a result of flows being mapped, like this Fisher 4 flow down here at the bottom, seeming to all appear at once. It's just from the mapping timeline. But more instructive is focusing on the actual flow front up here and how it's been advancing over time. So there you really can see how that flow continues to advance forward, and it was a lot faster running down a steeper slope before hitting the flatter part, where it still continues to advance, but in that slower fashion that we've been describing for a few days now. So there it is, and I thought I would bring up Kit Tincher's map once again, just to remind of the general flow path expected. I mean, it's still in this flat area where the 1935 flow that it's mostly on actually turned around Pu'uhuluhulu towards Hilo, but taking a long path around and stalling out before getting there. The 1843 flow that is also straddling took that path towards the Kona side and also stalled out not too far from here. It's just a flatter area, and depending on what happens, that could be a possible ponding area, but unless you see some change in the flow upslope, then there's no reason to worry about that quite yet. And so that's the interesting thing there, that flow's coming down, and there's a pathway. Now for comparison, Kit's put on here in this greenish color to the yellow to the orange and a little bit of red over here. This is 1984 Mauna Loa flow, so forgive me if I didn't see that at first. The red is the current eruption of 2022, and everything else here is 84. So I say this because I want to point out the difference in 84 from now. 84 actually erupted further down the rift zone at a lower elevation, and that put it in a different pathway drainage. So it was actually shooting towards Hilo in a much more direct pathway like this, right? So coming from lower down and actually pointing towards that Kamana area, whereas this flow has got this long way around. If it's going to go there, it's going to go a long distance further and across this flat part to actually get there and come from much higher elevation and sustain that drop in elevation, which entails the losing of the gas of the lava and the growing of crystals of the lava and all the things that help slow it down and have it stall out. So That is why there is no imminent hazard to Hilo, and there's no kind of evacuations or anything like that happening over there. If the flow were to continue for a good while longer in that direction, or change its character, for example, more fluid lava that takes a path in that direction, then it'd be a different story. But not every eruption does that, and so we want to assume that it will do that until we actually see that kind of change happening. So that's what happened in 1935, was the flow actually changed from mostly an A'a flow to a Pahoehoe flow, and formed a lava tube that was able to deliver it all the way down to the Pu'uhuluhulu area very efficiently without losing much of the gas. And essentially you had a new vent almost there that was feeding downhill, right? So you kind of had a satellitic storage zone. So that's not what we have going on, and unless this flow changes from A'a to Pahoehoe, which could happen at some point later in eruption. But if it doesn't, unless that were to happen and it were to come down and overspill and go ahead forward, then there's no imminent worry for Hilo there, or for the Kona site either, presuming it were to go in that direction. So one other thing that I wanted to point out from this map, which I thought was interesting, we've looked at this a little bit before, is the extent of these upper southwest rift, as is often called, which, I think the uppermost southwest rift, we really should define it as part of the summit, and it's almost a little confusing there, but there is a green of the 84 flows that didn't cover quite as big an area, but if you're looking at how far they flowed downhill, they actually they were actually pretty similar in their downhill extent as the 2022 flows. And so just to point out, that's a fairly typical thing that happens, and I know that was a worrisome time for Kona residents, but that's something that view for every Maunaloa eruption might be typical of having flows in the upper area, and it's not from there that you worry about it. It's when it moves down in some other direction from there, but that will probably cause some anxiety again in the future, because most eruptions do pop up in a summit and this upper southwest rift area routinely, regardless of which way they end up ultimately migrating. So that's pretty cool. And I also wanted to note in 84 we had a flow from that upper vent system that's almost a mirror image of the Fisher 4 flow that we have up here, right? It's interesting how that one went south towards Apala area, and then the one that we had this year went north, but it's almost equal downhill extents, and the shape of them is pretty interesting to look at that. Almost mirror images there. All right, so let me move on to some of the views, and I've shown this one before, but that's that wide angle view of that channel redirecting down through there, and that flow front jumping down at the bottom. This is a little bit more of a panned out view, and we do have an image from USGS of that area. There is that Maunaloa Observatory Road that's been cut off in several places here. There's an active channel over here, and there's an active channel back in here that both have lava in them, and we can zoom this in quite a bit. So I'm going to focus right here in the middle and zoom us in, and there is a lava channel. You can see all the darker spots in the channel are the lava balls and lava boats that are chunks of the channel walls, the levees, the cones sometimes, that will essentially be floating because they have a lower density than the lava itself. It'll be floating down the channel, and it's the volume of how much of this stuff that you have that can eventually clog the channel and force it to jump its banks. So that's why the appearance and occurrence of those are noteworthy. You can see down here where the flow is getting more diffuse as those two channels, right? And that's where it's heading down towards the front there. So that is interesting. And here is that upper channel, which you don't see lava that many places in it, but there's some there and there. And I'll zoom it back out again, and let me pull it back just so I can give credit to El Gallant, USGS photographer here. And this was taken yesterday, midday helicopter flight, showing lava flow branching after it cuts the Maunaloa access road. The large blocks in the channel are called lava boats, and these are termed lava balls or lava boats, and form one portions of the Fisher 3 cone or levees break away and are rafted downstream. As they move along the channel, additional lava can cool to their surface to form accretionary lava balls. So just some terminology there, but that's the long and short of it, is it's chunks of of less dense rock that are floating down. Anything that was more dense would just sink into that channel and drag on the bottom somewhere. So that is that view from the MK2 camera. I thought we could, let's give it a reload and see if our conditions have improved. It seemed like it was clear on a summit, so we still have a good view from the M8 camera there, the live feed. Still have a good view here from the M5 camera. A little bit further away. See that cloud layer, and there's a flank of Mauna Kea poking up behind it. M6 camera, clear up there still. M4, there's the channel. And from the volcano side, socked in from Mauna Kea 2. Oh, now we actually can see that upper portion of it as well. And the Mauna Kea wide camera, there's that upper portion of the flow visible. So that is what there is to see right now on the webcams. Let's advance to some other photos and videos. So we have this photograph still shot of the video from the Maunaloa Fisher 3 lava channel. And they describe here what we're going to see. This was yesterday morning. The large bumps are standing waves in the lava. Channel velocities here closer to the vent, where the channels are narrow, were measured at 26 to 36 feet per second, 8.2 to 11 meters per second. And Dan, you want to remind me of the speed of those in miles per hour? 8.2 to 11 meters per second.
Right, it was roughly 17.7 to I think like 22, maybe 24 miles an hour. Pretty fast. I mean, that's Fisher 8 territory. It's faster than Fisher 8 territory. It's really moving in there. But it's much steeper, right? And it's a much more chaotic channel as well. That Fisher 8 channel was pretty efficient in terms of getting lava down to the bottom.
Yeah, and relatively stable. We did see some of the branches get blocked off from lava as well, and eventually also saw all those lava boats collect in a narrow spot and cause an overflow and rerouting of the channel. In that case, it was towards a Halanui and Pohoiki, and that was that whole last month of the eruption phase.
Mm-hmm.
So interesting there. Farther downslope, the wide flow is advancing slowly, about an average rate of 20 feet per hour, 6 meters per hour. So just once again reemphasizing the difference in the flow speed in a channel upslope from the actual flow front. Those are two different things, right? So all the lava is in a very skinny area and a very small chute. That's why it's flowing so fast. And like I said, at the bottom, it's really spread out across a half mile, so it kind of distributes that motion across that whole area. So that's the screenshot. Let's play you guys a video. And here's a video taken of that river of lava moving, and photographer is panning to try to follow the crust. The cool thing to do, you see that chute there at the end that goes over the ridge, and let's have it looping here so you can see that.
Yeah, I've been seeing a bunch of questions about this video. Maybe you could talk through a couple of them here while we got it up. One is this Pohoihoi that you're seeing here, or is this A'a?
Well, that's a good question. It's kind of two ways to approach this, right? So the scientists are often trying to look for characteristics of the river of lava inside the channel to determine whether it's Pohoihoi or A'a. And looking at the stuff on the surface here, it does appear to have more of that Pohoihoi look. And generally speaking, you could have the lava coming out of the vent be more of that Pohoihoi
look
texture, right? More gas rich. Or if it were to spill out of the channel at that point, it would actually make a Pohoihoi flow. But that same flow traveling the extra, what is it now, 10 miles down that channel,
10,
could lose enough gas to be A'a on the way there, right? So it's a really tricky thing. It's a matter of like, so I've heard say the Hawaiian perspective is that if it's actually red and flowing, it's still Pele. And only once it cools does it actually attain one of those named textures, whether it be Pohoihoi or A'a or any of the intermediate terms that exist for the stuff in between. Right. So that's another way to think of it, right? But I get the question is trying to say if that flow were to actually harden on the ground, what would it be? Pohoihoi or A'a is another way to look at it. So yeah, it's a matter of how close to the vent you are. because the closer you are to the vent, the more gas you have in your lava. Right? We've talked about how the 84 reports show that the lava near the vent might have been 80 or 90% gas, and by the bottom of the flow is only 30% gas. So it's lost a huge amount of gas. Still has a huge amount in it, but it loses a huge amount. That's kind of one part of it. So the closer to the vent you are, the more likely you'll have that pahoehoe style lava that will, if it were to spill out, would be a pahoehoe flow. But also, as eruption goes on longer and longer, and there's less lava coming out of the vent relative to how much gas is coming out, like the actual cinders being shot from the vent in 84 were reported to have gotten less and less dense over time. Right, so the lava coming out of the vent itself is less and less dense over time. So the later an eruption you get, also, you could have more pahoehoe style lava, or lava flow that would generate pahoehoe further away from the vent potentially. And so it's all about how much gas you keep in there. And if you're this close to the vent where the flow is moving fast in a narrow channel, it might still harden as pahoehoe. But the further away you get from there, the more likely it's going to be an flow. So that's an interesting thing there. I wasn't going to talk too much about that 35 flow, right? But actually, what happened there was that initial lava that from the upper part of the rift zone found an old, whether it was a crack or a lava tube or something like that. It was able to mostly maintain underground, and it emerged at about 9,000 foot elevation is where it emerged. So it'd be kind of close to where that river is coming back together at the bottom. In that range of area, that's where the lava came out of the ground. So that prevented the gas from escaping along that whole upper. There was not a 9-mile channel down to there, right? So that allowed the gas to stay involved. Lava came out as pahoehoe, but because it was on that flatter ground and it was cooling and losing gas, it turned into And then later on, as eruption progressed, it eventually came out as more pahoehoe and made a lava tube, and that's what eventually went towards Hilo. And story for another day, got bombed. Right. So yeah. Is that enough pahoehoe and Have I?
Yeah. The second part of that was, I've heard some speculation about this having tubes or something going off of it and things along those lines. Have you seen much tube formation in this flow yet?
Not really. I mean, that's something where the lava level normally stays stable to be able to harden into a roof, right? So we are having blockages, and maybe blockages might be the first step towards having something roofed over. But typically that's something that you associate with pahoehoe flows in this area.
Right.
So really you're looking for that change to pahoehoe to then sustain, to be able to make a roof of the tube. And we just talked about how you can have an flow come down and then be overrun by lava from an event that might be more pahoehoe style. So you actually can make little tubes inside the channel of pahoehoe flow. There's all kinds of weird stuff like that can happen. But overall, the question is intended to, as far as delivery system, most of the channel you can see is open all the way down, and only a couple little spots where it's getting blocked and overflowing. So I would not consider any tubes to be formed really yet. What you do see as a channel is in the flows, the broad flows in the thermal image there. So that's more the nature of it. It's like a slurry that's coming out and fanning out there.
Right. I did see one image from earlier that suggests there was one tube that was formed, but it was one on one of those little offshoot flows. Not the main lava flows coming down, but one of those little side flows coming off. And it looked like it was doing something similar, but not the main flows. So that was kind of interesting. I don't have that photo available right now.
Yeah, I mean, certainly any pahoehoe flow could do that, especially on that smaller scale. And I'm trying to answer in the nature of the overall system. So yeah, definitely locally you could do that, and especially closer to the vent, as I was just saying, that would be more likely to find. So we're getting images from all over, and that's one thing to note is, are they from up on a hill or down on a hill, or because it's kind of two different regimes of flow. As far as you asking a lava nerd, there's two different things going on there. All right, so that's the first video there, and we do have another image taken from above. Looks like a possible another UAV drone shot looking down at the channel. And we know in 2018, this is how they measured the flow speeds, was by hovering a UAV over the channel and then shooting video and then measuring that flow rate at different points in the center and edges and different branches of the channel there. So there you go. And maybe that's an example right here, Dan, in this image. If you look right here, where this flow has a little area where it does seem to have a short section of tube forming right there. Right, there a little bit as well, but very localized here and not the main structure of it. So, and once again, we're close to the vent up here in the upper slopes too.
Does have that little bit of feature? No, it was further down, but yeah, similar.
Okay, so yeah, well, there's one example. Similar reports and a caption here, so I won't reread it. Let's move on. There's one other video released by the USGS today, and let me show you guys here. It's a kind of a compilation video. They're flying over, looking at the sunrise on a plume, looks like. Different views of Fisher 3. This is earlier on when it was still putting out a channel to that southeast. The Flowfront itself, I do have this sped up, by the way, just so we can move through it here. So you see the technician installing the webcam. Webcam is placed, solar panel coming out, getting wired up and connected here. Everything secured. Turn around. They're doing the sighting measurements to measure heights and all that. They also are shooting thermal cameras. There it is, documenting the temperatures and capturing that image. Back down to the channel where there's a little branch making it's like a slabby offlow there. And there's that next video from USGS. So that is imagery, and we've covered a little bit of it all, and obviously there's a lot more imagery out there, and we're not focusing on imagery so much this time around, just because that's something we think you can find on your own at this point in time. So switching gears here to the VOG, the VMAP forecast is showing just localized spots of potential VOG impact, because most of the plume remains in the upper levels of the atmosphere, limited impacts on near-surface air quality expected. But conditions may change rapidly. And so the forecast you see for the next couple of days, it's kind of swirling around, and then it'll seem to accumulate in the Kona side more so a couple of days from now if this holds, if this forecast holds. Let it play through to the end here where it actually starts pushing through the Kona side right there. So there's that. I wanted to show the windy once again. Maybe you can't see, but Hawaii Island's, too far. Hawaii Island is right there, right in that deep red color. So zoom it out, and we have a weather system which is pulling this VOG. So on a global scale, we actually had a lot of this VOG flying over here, and it's getting detached, and this bit is getting cut back in here. And so this is a little bit of an unstable pattern. That's why we're having these potential weather events here in the middle of the island and possible thunderstorms and all that. So I thought we should check in once again on the sensors, because this is when you might get some funny stuff happening. The Department of Health from the state isn't showing anything abnormal here. Everything still looks to be in the green. I'll come to purple air. And now you can see there's quite a bit of yellow on these maps, right? Because these are also measuring shorter time intervals. So looking at Hawaii Island, you can see quite a bit of area that's having impact. Volcano is by itself, probably because of Kilauea. But now you're looking at areas here, like this is somewhere near Waikoloa. And you see there is a graph. Let's see if I can zoom it in here. It's been in the green, but you see it's been climbing up and dropping down, and this is likely that weather bringing that VOG to localized areas. So certainly an issue. We did have a report, despite these green dots on a map in Hilo this morning, that there was a little sulfurous in Hilo this morning too. So you can really see here, not just the northwest side of the island primarily now, But you also can pan over to Maui, and there are impacts happening there as well, it appears. So it could be that that storm system is pulling the fog across the islands here, and maybe pulling it closer to the ground because of these unique conditions we have going on now, right? It's worth noting some of this is also not volcanic, right? You know, when you're dealing with cities, you could have also other possible sources, and I just don't know enough to tell you about exactly the details of Honolulu or Maui, Oahu or Maui here. So, but more than likely, this is not what we typically see on Hawaii Island here on this side. So there does seem to be a little extra impact happening right now. International Park itself, here's the air quality in the park. Here's the charts. Been in a green for most places most of the day. Here at Uikahuna, particulate matter has spiked a couple of times. Not to the red, but to levels that might be affecting sensitive people. So if you're in a national park, just follow their guidance, their signs. They do a great job of keeping visitors aware and give them safe places to go. So we've covered the basis there, and because this is kind of a little bit of an unusual event, we will restate that there is the Maunaloa Fog Detection Survey we've put out there, and Dane, you can drop that in the chat again if you like, and say a few words if you like about the survey that's still ongoing. We're still collecting data.
Yeah. So yeah, we're collecting this data to try and help out. This survey is based on the survey that was done in Iceland and is still ongoing. It helps them refine their forecasting and the placement of all the sensors, things like that. The thing is, with Mauna Loa, we haven't had a real-world test on any of the placement of sensors, any of the models, anything like that since 1984, before all of this technology was really developed and tuned and all precision and all that kind of stuff that we have now. So we're getting that real world test now, and we're trying to collect the data from people, right? Because right now I've gotten a bunch of reports from guys where you would think by the sensors everything would be completely normal there, and they tell me it's not. And, you know, I believe them and all that kind of stuff. So we made a survey, dropping it in the chats, and that survey has been ongoing, and it's going to continue to go throughout the eruption, try and get people, if you've smelt the fog, if you haven't, if it's tingled your throat or irritated your eyes, all that stuff counts, and it will, you know, help us revise things later, and be able to actually do things like accurate fog forecasting eventually someday. You know, it's always a process and trying to refine it and make it more accurate. And then when a real world test comes, then you get to figure out how much of the theory is going to hold water, right? And right now, you know, we're getting that test, and we need to do as much as we can in terms of data collection, because the eruption might not last all that long. You know, Mauna Loa eruptions aren't known for their longevity. So, I mean, they have gone long time, some of them, but, you know, this might be a quick opportunity, and we need to grab as much as we can. And who knows how long the repose period after it ends will be.
Yeah.
So yeah, that's the survey.
If you fill it out before, you can fill it out again. Different day, different place, same day. All that's data points that are welcomed. So, yeah, if you can help, appreciated. So that is the Mauna Loa section here. Of course, there is earthquakes. Let's look at earthquakes under Mauna Loa as well, and then we'll switch over to Kilauea too. So there is the earthquakes on Mauna Loa, and there's actually the whole island, sector of the island here over the last day. So on Mauna Loa, not a huge number of events. However, there are some big ones. This one right here was a 3.5 that occurred 2 kilometers above sea level. So that's halfway up to the summit. It's right in that shallow part of the volcano. 3.5, and it was followed by a whole bunch of other events: 1.5, 1.9, 1.7, 1.9, 2.1, 2.3, 1.9, 2.5. All today in that area. So certainly adjustments still happening there. 3.5 is still a decent size adjustment happening. So let's look in a little more detail of what's going on there. But let's also note there's not a whole lot of earthquakes happening in Kilauea at all, right? We're getting some down here in this Pahala area still, but really nothing on the near surface of the volcanoes, of the volcano here, Mauna Loa, we'll talk about here next. So on Mauna Loa, the top here, Earthquake numbers are still down overall, so they are occurring, and we did have that extra energy released by the 3.5. But overall levels are low, and in the context of the last year, here is the last week, and this week is coming in a little bit lower. In the context of the last 5 years, here is this past month, which was the highest point when eruption occurred, and here we are starting a new one. Won't see much on there for a while. Here's a pattern for the whole last week, showing not just where that 3.5 occurred, but all the small ones that kind of accompanied it. And that's generally following the pattern that we see here for the last month that includes that eruption. So it's similar areas still that are activating. Maybe a slight difference in that you're getting a little bit more. So you can see this one kind of tails a little bit more to the west, southwest there. And this one tails a little bit more to the south. So that's just the areas that are needing to adjust further after that dramatic change at the summit here. So exactly what the change was, we'll have to look at the Tilton GPS. And this is the 1 week tilt here. So it's going down, which means the volcano is deflating, the magma is leaving the summit area. You do see this big jump and drop. That's that 3.5 earthquake. It's not exactly clear the details of this. We'll have to wait for the USGS to say more, perhaps, if more is known. You see, it almost looks like a double line here, right? So it's like it jumped up once and then again. So it's possible that you had some little magma movement coming in there that was just localized, caused a little bump, and then that was that. It resumed its previous pattern of deflation. It's not quite clear if that was the case. That could be happening still. Everything's adjusting. There's magma in there. It can move around. But it's more about if you see it really jump all the way up, that you would be concerned about it being an eruption. And so for comparison, here's the last month, and there is what the eruption looked like, jumping way up and then coming back down. And here is our event that we just had last night. So continuing the same trend, possibly was a little extra movement in there. Not exactly clear, but the big picture, if you look at the GPS, distance north to south across the crater is still contracting. You can see it actually during eruption got wedged way further apart, wedged open, and now it's sagging back together slowly. It hasn't reached the same level, probably won't for a long time still, but the trend is of that distance decreasing, which means it's sagging closed, and more instructive is looking at the vertical signal, the up signal on MLSP here. And this is a year-long plot. We have to zoom into that whole right end again, and there is that magma moving during eruption, and then since then dropping down, 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 down. So if there is any little bit of magma coming in, it wasn't enough to push anything upwards at all that we can tell. And actually we see that these dots are getting a little bit closer together here. So it's still dropping down, but that rate is slowing. And at some point, we'll expect it to bottom out in some manner, right? Whether it's more down or slow in some way. So whatever is happening up there seems to be mostly an adjustment of the main eruptive event rather than something new going on, which is the key distinction here, because something new going on might open a whole new can of worms as far as what could it do, what could extra hazards be, and it's something to be aware of, but it's not what is being shown in the data. And so that's 5 years. I think that's enough. But we did have a question about this one a couple weeks ago, or a couple of days ago. I'm saying a couple of weeks. So the SLC Sleeping Cave Station up here on a upper southwest rift area, 10,000 feet. There is a line, and it shows this offset here and kind of the stepwise in both directions, right? So the azimuths are 0 and 90 degrees there. But in any case, this just means that the ground shifted and then stayed offset, and then what you're really looking for is a trend within this area and a trend within this area. This is the the mountain jerking open when lava was coming out. So the ground moved and it stayed moved. All right, so moving on from that, we're going to turn to Kilauea now. And on Kilauea, this is last night, time-lapse being made of the F1 thermal camera and also the KW wide-angle camera up on a rim. So the main persistent lava lake, Has had lava circulating through it consistently for a long time now. I want to say it was back in March maybe that it last crusted over. Just off the top of my head there, I have to go look that up. It's been a long time of continuously flowing, and it's finally seemed to be having the whole crust harden at the same time and crust over. It's not completely stopped there because that crust, once it forms, prevents the gas from escaping. The gas can then punch its way through that thin crust and creates an overturning process. So fresh lava comes onto the surface, resurfaces the whole lake, and then will harden once again. And so it goes through that. It can do that for up to a week after the lava stops coming into the hole in the first place. So it takes some time for it to shut off. And if that's what it's doing, it could be doing that for a few days still, where it flashes bright and then darkens and cools, and then flashes bright again and then darkens and cools. So to get a better handle on that, let's update the view here. Let me reload this for the last 24 hours from the USGS on the webcam. There's a current view. You can see it looks like it's resurfacing right now, coming from a spot over here, but there's a section of crust that has not been recycled yet or covered. And there is that zoomed in version of the last 24 hours, showing the various states of lava flow on that hardening crust there. So interesting to note, this change on Kilauea. Let's keep moving through the cameras. Let's look at a couple more. There's a KW once again. That's the view from earlier when it was still light, and let's reload it. So in the darkness and through all the clouds and fume, there's a glow from that west vent pond or west vent area, and the lake itself is showing some glow from lava and that resurfaced lake, but not as much as a whole open surface used to be. So viewing on Kilauea does appear to be not as good at this exact instant. And there is that visible for the last 24 hours too. West vent here, and it looks like the west vent pond, which is more in here, is the one that was glowing at night. When we see this image is right in there. So one more camera, let's look at the V1. This is from earlier. You can see the beginning of one of these overturning stages. There's a little bit of lava just breaking through what's otherwise a completely hardened crust. Let me reload it. And now you see there is that bubbling up spot and a resurface flow across the whole thing, but definitely not all the way liquid like we usually see it. Past 24 hours, let's put that on the screen too. Get it centered here. There we go. So sometimes brighter, sometimes less. One interesting thing you can see is that as the lava level has dropped over time, you see more of that far bank exposed. And actually you see a collapse of the wall occurring in this section right in here. And maybe I can zoom it in so you can see that. Have to wait through the dark for it to come light again and have the controls on this automatic GIF. But there is that wall intact, and there it is collapsed. Clear view of it collapse right there onto the surface. Interesting to note those little changes. So keep an eye on that. If this continues to actually be a full-on pause on Kilauea, Dane, it will have to stay paused for 3 months for it to be considered over as an eruption. So if anyone is asking, is Kilauea eruption over? We have this measuring stick of 3 months that we've dealt with before, yeah?
Yeah, and we've also dealt with periods in this eruption where Kilauea would go away for a couple days, right? And then reemerge and the eruption's unpaused and it's the same eruption and we're continuing on. We haven't seen that in probably, 8, 9, maybe more months, that type of effect there, but we've seen it before. It kind of looks a little different this time, but hey, it's just hard to know when Kilauea will quit that lava lake because it seems like it can keep going with minimal effort.
Yeah, and we have noted that the lava has been filling mostly underground. It's not that Kilauea itself is no longer active, it's just that it's not making to the surface anymore. Right. Your Kilauea webcam views, I can scroll through some.
But it still has that pretty clean pathway up to the surface, and it shows that it's still able to get stuff through it. Interesting time
potentially.
on it.
Yeah, potentially. Yeah, I mean, as I said, like we could potentially have cut off that feeder But if so, we might see some signals on the monitoring instruments, and a lake could still resurface for some time. We've also seen it blocked temporarily before, and then we've seen it cleared before. We've also seen it blocked and an intrusion happen underground before, and then it resume as well. So all those are possibilities and options that are still on the table here.
Yep.
So that is, that's the Kilauea visuals. Let's look at the Kilauea monitoring. There is our plot of lava depth for the last week, and we do have a whole bunch of extra false readings skewing our depth once again. So we'll just zoom way in to the last day here, and you can see that here in the last day, there it is, the lava level dropping a little bit faster than it has. See, it's been dropping for a while, like all week. It's been a very slow drop, and then slightly faster here than the last day or so. And you can see that that's not exactly the pattern of the tilt. Now the tilt, maybe, you can see the tilt's coming down. Maybe that's a downward trend if you just pick those 2 points there. Hard to say exactly. There's a lot of deflation inflation still happening, so a lot of variability down below in that feeder system. There is that month-long pattern. It's been decreasing since about, I'd say like the 16th, if I had to pick a point on here, right? The 16th. That's close to 2 weeks before the Maunaloa eruption. So those of you guys who are wondering what kind of connection and the timing of all that, it's not exactly lava coming out of the ground that may affect Kilauea, but it could be the underground adjustment of Mauna Loa itself. If it's making any effect, it's happening before lava's coming out of the ground up to 2 weeks ahead of time, right? And potentially you could argue back to September 20th, there was an intrusion under Kilauea as less magma made to the surface. And this is touching on that research that we mentioned previously, and I'll show it again today, about how Mauna Loa's shallow system, when it swells, can then close off Kilauea's shallow system, but still keep its deep system open. So magma can still come into the volcano. So over the last month at the tilt, it's, because of all this deflation inflation events, it's not quite clear where you draw like a average line, right? The highest peaks that we see are maybe slightly down. Also, maybe if we to do this, we could, but yeah, I don't know. I wouldn't be so confident drawing a line like that. So it's not quite clear with so much deflation inflation exactly where the average is, if the tilt's really dropping at all, or if it's kind of stable. It's not really clear that it's crashing, right? We could have a pattern that's going down like this. The deflation inflations, we're not seeing that. So it does appear relatively stable overall. That's what the USGS update also states. We have seen gas emissions going down, no recent measurement, but it's just restating a trend there. And for the last year, here's that trend of SO2 really decreasing back from May, right? Downward trend for a while. So the eruption wasn't going to last forever. Potentially, it was going to come to a natural end and resume like we saw happen back in May of 2021, where that first phase of sun eruption that had lasted, December, January, February, March, April, May, 5 months, then 4 months off, and then came back September 2021. So here's the one of the key things. This is the 1 year summit GPS, and this is the distance north and south across the caldera of Kilauea. And this line is still going up. So the sides of the caldera are still getting further apart. And that's the signal that's showing magma injecting to the volcano at depth and still coming into the volcano, still swelling it. Right, that's that's north-south distance. Sometimes it catches, and this is when we had the intrusion, was when it caught and it became less efficient. Not just shallow, but at depth as well, and that can happen at other times. We're going to show that the dynamic nature of this connection is maybe not as stable as it once was. On the rift zone at Pu'o'o, this is the Pu'o'o to Jacuzzi length, the line is still going downwards. The distances are getting closer together, which means that there's not magma coming into this rift zone. So regardless of what's happening at the summit and of the lava actually crossing over at the summit of Kilauea, it's not going to the east rift zone, and there's no concern for public hazard at this point with this eruption. Right? As we keep stating, the volcano does readjust continuously all the time, so at some point it will reoccupy that area, but we're not seeing signs of that yet. So that's the story with Kilauea. There is a Kilauea daily update still coming out. We haven't covered them most days because there's not a whole lot of change, and honestly, not a whole lot of change in today's update either from 9:28 a.m. No significant changes eruption continued over the past 24 hours. They note that the lake has risen and fallen about 1 meter, 3 feet over the last 24 hours, but it's the same as the start. And otherwise, tilt records are stable, tremor above background, SO2 last measured at 316 tons per day. So nothing really new there. They really don't even note the cresting over process happening. So we'll see if there's a change in that tomorrow as it's more obvious and clear. So that's the Kilauea. And the question I'm sure is out there already, what's the connection of these volcanoes? And I've often said these volcanoes are leaning on each other. So I thought I'd pull out this graph, which is often in my head, but I'm not sure how often I've shown it. This is from the paper of displacement of the South flank of Kilauea volcano. And what we have here, let me maybe make it more clear, right? We're looking at 3 lines when it goes from offshore Kilauea across the summit of Maunaloa, across the summit of Hualalai, when it goes across essentially the summit of Kilauea and the flank of Mauna Loa to the edge of Mauna Kea, and then one that goes across the east rift of Kilauea, or farther from Mauna Loa to Mauna Kea there, right? So I want to focus on, let's just focus on that one to start. It's the one at the very top. So at the Kilauea end, there's the A. There's Kilauea. Kilauea is this dark hatched area, right? And it's sitting on the side of Mauna Loa, because Mauna Loa is older, and Mauna Loa is sitting on the side of Mauna Kea, which is older. And in that cross section, Mauna Kea has been buried by Mauna Loa in that saddle region. And because we're going through the summit of Hualalai, then you have Mauna Kea on top of Hualalai, which is older. And further off, if you were to keep going, Hualalai is over Kohala. So this is what I mean by the volcanoes are all leaning on each other, all stacked one on the other. So as Mauna Loa inflates, right, it's pushing this whole structure of Kilauea, and Kilauea is affected as well. And that's how the volcanoes can affect each other, right, especially when looking at the summit. So the next line down is a little bit more northeast rift in Kilauea summit without Hualalai, right? We here have Hualalai as the older than Mauna Kea lava flows down at depth, Kohala underneath them, Mauna Kea here at the surface. But there you have the same thing, northeast rift push on Kilauea, and that's what I mean by these things leaning each other, and often described as imbricated volcanic isles here. So that's the actual physical arrangement of them. And here's a paper we highlighted a few weeks ago. This is in Nature Scientific Reports. This is an open report. The elastic interaction between Mauna Loa and Kilauea is evidenced by independent component analysis. So these guys are using differential INSAR and are using this computational technique to try to computationally pull out the different components of the signal from a differential INSAR. And so a lot of the paper is actually validating the method and looking at all the details and talking about the methodology and all that. So I don't suspect most of our audience is going to follow along with that. But I do want to mention that that's what it's about. It's going to jump to the one figure that's going to help you guys understand what's happening here. However, I do want to give credit to, let's see if I can get some names here. Monica Prezior, Luca Dauria, Suzy Pepe, Pietro Tizani, Ivan Cabrera Perez. They are from research groups in Volcan and Canary Islands, ITER, which is in Spain, and IREA, CNR, and Naples, Italy there. So Spain and Italy is where these researchers are. So moving just to the chase here, here is the figure to show you guys. They've pulled out all those components and analysis, and they've then done a 3D numerical modeling of the strain fields and the stress, like how much pressure and displacement can occur from one volcano pushing in the other. And the key to this is, let me zoom it in, is what they find from their results of the component analysis is that the actual blade of magma underneath Mauna Loa, it's exaggerated here. This is not exactly how it sits to scale, right? But that blade of magma under Mauna Loa actually faces towards Kilauea. So as it swells, it can actually put pressure in that direction fairly efficiently. Kilauea has two different magmatic centers, a shallower, more spherical or oval reservoir system that's marked as number 2 here. And then a deeper one that's often thought of as a larger system, but their analysis actually suggests it might be a sill. That's a blade of lava, but instead of being a dike that's up and down, it's flat, horizontal, injecting between layers of lava. And so when it swells, it puts pressure kind of up and down, right? Not towards Mauna Loa. So the key effect is, if you look at when that blade of lava under Mauna Loa swells, then the red is where it's putting extra pressure and displacement. It can actually push, and it can create an effect on especially that shallow chamber of Kilauea, not so much the deep one, because the deep one's at the wrong orientation. They're kind of at the wrong angle to each other. So that's the effect of Mauna Loa. Can then, when Mauna Loa's shallow system inflates, it can essentially inhibit or help pinch close Kilauea's shallow system while leaving its deeper system open. And the reverse is not true, right? When Kilauea's shallow system, or this is actually that deeper reservoir, when it swells, it can affect the shallow system, but it cannot affect Mauna Loa based on its modeling. And here, the shallow system really just affecting the localized area as well. So Mauna Loa shallow system can affect Kilauea's shallow system, not a steeper system. And we've just seen magma come through this whole area and push sideways. And even before it came out of the ground, it was doing that, preparing to erupt. And that could be why we have started to see these changes in Kilauea starting back in September with the intrusion, which this is the effect where possibly lava is reaching the surface less easily, but still building up underneath the volcano. This is one of the many concepts of these volcanoes interacting, and I don't want to go too far off on the tangent there, but I'll just leave it at that. But that is one way to present today of how they can actually affect each other. So one last thing I wanted to mention is just this tweet by Rob Simon, pictures by Planet Labs here. Pictures of before and after of Moku'a Ve'oveo crater, the summit Mauna Loa's caldera. Before and after the eruption, the summit that just happened 9 days ago. So the lava here is silvery. You can see actually a little bit enhanced too, but it shows you that fissure across the center of the caldera there. Looks like there might have been a little bit of section of fissure here and here as well. A fissure off the southwest there. It looks like it actually erupted out of the 1949 cone and flowed south a little bit. And that's kind of the before and after. You can see here the previous flow from 84, that's what this lighter colored here is, didn't quite make it to the southern wall. I can zoom it in to show you guys. There's a little bit of a gap right there, right, of that older flow. But the new flow that we just got does look like it went all the way to that wall in that area. That's one of the little differences, for example. High ground over here was still not covered, but there's still a lot you can look at, right? There's a 1940 cone. Looks like that fissure came up along its eastern side and then offset to the south. You can see an extra crack there, but there's the actual, seems to be the continuation of this fissure here, going across. Hand it over. That looks like the 1949 cone with a flow that comes out of the crack on the upside of it, on the edge of the caldera there, and it flows back into the crater. Something like this, maybe. There's other similar flows from 49 in the area, so this might take on-the-ground mapping to confirm exactly where the boundaries really are. But something funky happened in here. It looks more and more evident that that's the case. And then there's a crack with the flows issuing off, right? And if you look closely, there's actually a little bit of change where that flow comes off the map and back on. Probably more in here, actually, but you can see a little bit of that flow into the South Pit crater, too. So interesting stuff. I want to pan it all the way back to the right. And here at the right edge of that, there's North Bay. You can see there's that, looks like a fissure maybe here, and maybe this crack also putting out lava flows as well. So interesting to look at in more detail, and I'm sure we'll have to look at mapping efforts that ground truth all of this to get more details. So that is the last thing I wanted to share with you guys, so we can turn to some questions, Dane, and then go get some rest.
All right. Well, first, want to thank everybody that tuned in today. We rely on viewers like you to get this information out there. If you like this type of information, we take a lot of time to try and ignore the hype and get you what's really going on. Make sure to like, subscribe, comment after the video ends. All that stuff does help with the algorithm. Moving on, we did have a bunch of super chats. Want to acknowledge those. We had Judy Menzel come through with $25. Says for staying on top of things. Appreciate it, Judy. We had a $99.99 super chat from Love the Color Orange. Says thanks for the detailed updates and all the work you put into it. Appreciate that big super chat there. And then we had a $9.99 super chat from Orchid Isle. No comment on that one. I believe there was a GIF. Steph comes through with $5 and says, I really appreciate all the great info you guys provide. It's always so interesting. Thank you. Daniel Dawson comes through with $19.99 and says, I really enjoyed your informative updates and attention to scientific detail. Keep it up. And I think that gets us through the super chats. Appreciate everybody that tuned into that. We also post on hawaiitracker.com and we do take donations there as well. Appreciate everybody that donated on hawaiitracker.com. I don't have a list of names or anything, but appreciate everybody there. All right. Ready for some questions?
Yeah, let's see what we can discuss here.
All right. I've seen this question a lot over the past couple of days. Mark asks, is the rate of lava coming out of Fisher 3 staying steady, or has it increased or decreased?
So, since when? Yeah, so I think it's really hard to tell. That's the bottom line of it. It's really hard to tell whether it did increase or decrease there.
Right.
There are a few little hints that we can look at, and there's a few things to consider too, right? So let me have a graph from the 84 eruption I wanted to throw up here. So let me throw this on here and just talk about how things went in 1984. So time is on the bottom. There's the end of March, and then April was about a 20-day eruption, so that's the 20 days right there. And this is a very generalized plot. This is the center line, and anything going up is increase, anything going down is decrease, right? So let me zoom it in. So lava temperature and composition stayed the same throughout the whole eruption. Didn't change at all. Came out the same temperature the entire time. Temperature didn't go down, anything like that. Composition didn't change. So it was one batch of magma feeding the whole eruption, right? That's what we expect is happening here as well. The temperature of this eruption is a little bit hotter than one of 84. But expected to kind of be the same temperature and composition. So hotter might be slightly gassier to start, and we'll see if that's the case and how much volume it actually attains. So looking at the bottom part here, this is a discharge rate. So this is how much lava is coming out, right? So typically what you see is it starts off at its highest rate, and it drops down. It kind of stabilizes. It might be decreasing more slowly, but still decreasing. And at some point, it's going to really crash out. So I would say that we're probably in this phase somewhere in here, in this middle part of it, right? We haven't seen it crash, but we have seen what used to be two fissures erupting, reduced to a single fissure erupting, and it's still coming out really a whole bunch of that one fissure, but we're able to sustain that and another fissure earlier. So that might have been that earlier phase. Those first few days might have been this upper part of the curve here. So I can't tell you exactly how much, but you expect it to kind of decrease over time, sometimes slower and sometimes faster. It seems like we're in this phase right in here, so it's not exactly an answer there to Mark, but I would lean towards relatively steady, slightly decreasing, just based on expectation, because we don't have any measurements to really guide us otherwise. I guess there's one other thing in the graph I can talk about up here. This is the other part of it, the top part. What's increasing over time is pre-eruptive degassing, how much gas is coming out up at the vents, and also the abundance and the growth of microphenocrysts. These are these very small microscopic crystals that are growing in the volcanic ground mass of lava. So yeah, very, very tiny microscopic crystals, and as they grow, they can ultimately become a huge part of the lava itself. And I did see a question earlier, and this kind of relates back to the Pahoehoe and A'a discussion of like, why might a Pahoehoe flow turn to A'a, right? One is the actual slope where it falls apart and releases this gas and kind of tumbles over itself. That's one thing that can happen. The other is it can also be growing these crystals, and when that happens, then it also makes it more viscous, essentially, and that helps slow it down and make it right. As far as the raw material is the same stuff, but it's more about how much gas is mixed in and what kind of slope is flowing over and how it actually mechanically flows, whether it gets ripped apart or whether it can stay coherent, form a coherent skin that can insulate the whole thing and keep the gas inside. So hopefully that's a bunch of questions all in one with one graph here for that reason there. I can't hear you, man.
Oh, sorry. Patrick asks, how tall is the terminus of this flow? Does it vary, or is the end glob all the same height?
We don't exactly know. Also, we've been told it's about 20 feet. That's the most reliable measurement that we've heard at the actual front. I'm trying to look at the time-lapse videos, and I think it might be slightly thicker in the middle, but how do you measure that exactly, right? Unless you can, really do a whole 3D map of the thing and maybe if it's better weather.
And then subtract it, right.
Yeah, but right now, we've heard about 20 feet. It should be expected to vary from place to place. It kind of depends whether the whole thing is evening out altogether or whether one lobe is feeding more than the other. So if it's one big channel coming in, then maybe it's all more even around. But if we have two different channels coming together, then maybe you have variable rates from one place to another too, and variable heights too. So that's a good question. We've asked that, and we're still trying to find better information. But roughly 20 feet at the very front seems to be a good number to go by.
Right. Next question. Smoke asks, what do you make of the continuing earthquakes on the west side of the summit area or the Caldera area, like the 3.5?
So just to reiterate, we went through all that. I think we still see the summit dropping in elevation, so it's really got to be an adjustment to the magma draining from the area towards the eruption site, right? And adjustments to that, and we do know from the INSAR there was magma emplaced in the upper southwest rift area and that upper northeast rift area both too. So adjustments to all the changes, emplacement of magma in some areas, and then the drop of the ground in others. So still adjusting, and the concern would be, and it's a good question because that's the concern, is if new magma were to come into the volcano, like a second batch that was, let's say, hotter, right? If that would be the case, and you essentially have a piggyback twin eruption in some senses. So that's something you want to make sure is not going on, and we don't see any signs of that happening at present.
Right. Next question is from Arthur, and he asks, do you guys know of any perched lava ponds from previous Mauna Loa eruptions? What conditions might be required to create such a feature?
Yeah, good question, Arthur. I don't know of any offhand like that. There is an interesting, depending how you define it, right? The 35 flow is said to have ponded in the saddle region, and it was kind of ponding on that west side of Pu'uhuluhulu, fed by the Pahoehoe lava tubes. And once it made a turn around Pu'uhuluhulu to the east, that lava tube drained the whole ponded area, and that's when a concern for Hilo really began, because that flow had been kind of inching forward a little bit, quarter mile, some fraction. And then one day it went forward a whole mile when that tube opened up. It went 1 mile towards Hilo as Pahoehoe. And that's when people got really concerned. Okay, well, if it keeps doing that, it's not going to be too long before it continues getting steeper and steeper slopes downhill, and it's going to guaranteed go into town. So that's when they decided to bomb it at that point in time. And leave those details out for now, but that's why.
Right. Well, to me, I immediately think of 2018 and some of the perch ponds we saw there, primarily when it was working its way back up the rift, and it was down near Poiki Road and Leilani Avenue. You remember those perch ponds like Fisher 15 or something like that. And the thing that immediately jumps out to me is you need flat land, a relatively lot of flat land, and a very high volume output from a source, right? That's hot and all that kind of stuff. Really hot to keep everything hot, and flat to make it so it ponds and not just runs down the hill type of thing. So I don't know. That is an interesting thing.
Yeah, I mean, I know Arthur knows it. Like between Pu'uhuluhulu on Kilauea and Manaulu, that little tiny little saddle between the cinder cone and the lava shield was enough to form a perch pond right there, small scale, and
Right.
it wasn't the final destination. Like that was like an intermediate stop for the flows in the flatness, and then continue down the hill further from there. So, it's a similar setup now. You have a big saddle between Mauna Loa and Mauna Kea, and you have a similar flow. I mean, the scale is much bigger, Arthur, right? But it's very similar in that same configuration. So I think it's a great question there. But it's more, can you sustain that lava fluid enough to pond it down at the bottom? And that's where the lava tube question you asked yesterday was really good for creating those conditions. It helps to have lava tube delivering the gassy lava down to that flat spot to then allow it to kind of pond up and overflow and then build a perch pond feature by actually being able to flow out rather than just being that pahoi clinkers that's kind of pushing and all that. Right, so that's the best answer I can give to those great questions.
Right. I think we've gone through a bunch of them. I did see somebody wanted to ask about Pu'u'o and the potential for it reactivating. Any chances of that, you think?
Well, it's an area that's been active a lot in the past and will be active again in the future. And my answer has always been that if it comes out of that spot again, it most likely doesn't come out of that hole on the bottom, and it comes out of some other crack right near there,
right,
and builds a new feature, and then what you name it is a whole different consideration, right? Because it's not exactly the same vent, and so you could have a whole new feature with a whole new name, and it would not be Pu'u'o, even if it was very close to Pu'u'o. So that's kind of complicated. It's not too common you have lava come out of the same crack more than once. It will often break right next to it or a little off to the side. And it's funny, I was looking at the Mauna Loa images here, the Moku Ve'o, and because it's cracking open in a more coherent fashion, some of those cracks might actually get reused in the area, but it seems pretty close to. You often form new cracks within a few meters of the old ones. So that's really fascinating to see. A new vent just to the side rather than coming up the old crack. And one thing we've talked about in the past is how after the lava erupts, the gas escapes and flies upwards. You essentially have flat, more solid, hard, more dense lava that wants to drain to the lowest point. Quite often it's back into the cracks where it came from, especially if it's in the crater. And if it does that, it can actually plug that crack with a more dense lava that's on the surface. So that might actually be like a scar, almost like a scar tissue area where that particular crack is stronger and it might not be able to push through that, and it's easier to crack just to the side of it, make a new path to the surface. So one of the reasons why very often the same crack doesn't put out lava more than once. So the same thing true, Pu'u'o, lava draining away into it down there.
Right, 2 quick questions I'm going to take real quick. Matt asks, any idea how close they'll let it get to Saddle Road before they closing it? And it's going to be pretty close. Though probably within a day of it taking the road will be about when you're expecting a closure. So with 24 hours notice before it takes it. And we'll know as it approaches. It's still, I want to see a little bit more measurements on the thing. It kind of jumped a little bit too much for me to really have. I want to see these numbers verified again for the Civil Defense's numbers that they're putting out. Because it was 1.93 this morning by USGS and their field crews, and to get at 1.5, I'm like, I got to see it, type of thing.
Well, they say approaching 1.5. That could mean anything, right? So we'll have to see what the exact.
I know it just seems like a rounded number that was just plugged in. The 1.93. That's a precise number type of thing. That's the one I'm like, that's probably more around there. So, anyways, they're gonna let it get pretty close, and we'll know, when it's right near the thing, and it's about a day out. That's when you can expect the closures to be coming and things along those lines. Other question I saw is, do people really cancel their vacations from things like this in this eruption? Yes, 100% they do, and it actually hurts the tourism economy and the economy, which is structured upon a tourism-based economy as a whole. You might hate or love it, but that's the way it is, and it hurts significantly. In 2018, we took over $400 million as an island in damages, basically, from that eruption, and a lot of it was due to vacations being canceled, things along lost revenue, right? So big hit in terms of that. And a lot of it has to do with, people not having the real information, and they think, half of the island's going to slide off into the ocean or something. So they just panic cancel, right? It happens. It happens a lot. And that's part of what we're trying to do is prevent that from happening as much, right? Never going to completely get it out of hold, but even if you take 1% off of that, it's a big, big amount of money that you're talking about, keeping on the island and in the economy.
Well, yeah. So thanks for getting the right info. You guys know that now that there, despite some people's alarm, we are not alarmed ourselves yet. I mean, obviously we were very alarmed at the beginning of this eruption, but the way it's settled in and stayed focused at the vent and seems to be fairly stable now makes us a lot more calm about that. And the large distance towards either Hilo or Kona area from where it is now and the time it would take to navigate that pathway gives us more confidence, combined with the typical length of time of the eruptions. It could go on for a while, in which case it develops into a more dangerous situation. But on average, what we would expect, right? There's a difference between worst case and average case, what to expect, and we try to give you guys both. And average case would not give us any concern for impacting people. Worst case would be cutting off the highway and in the short term, right? The worst case would be cutting off the highway and disrupting transportation east to west. And then long term, if it were to go on for months further than weeks or months further than we cross that bridge when we get there. One last thing, Dane.
Right.
Just looking at the USGS numbers, it looks like it's advanced roughly 0.2 miles for the last 3 days per day, or 4 days actually.
Okay.
0.2 miles,
last
0.2 miles,
3 days,
0.2
yeah.
miles, 0.2
Yeah.
miles from Saturday to Sunday,
Yeah.
from Sunday to Monday, and Monday to Tuesday, and about 2.2 miles each day. So, you'd think that, okay, if it's like within a quarter mile or within a half mile of the road, maybe you start thinking, okay, if you really think it might go half mile, then that's when you start putting your plans into motion. So we'll see. There's one thing I can maybe show. Let me see if I can find it here. It's tricky to find exactly, but here, let me put this on the screen. This is from Google Earth, and there is Pu'uhuluhulu, and I don't have the actual current lava flow on there updated, but it's, let's see what I can throw on there. A few days ago, there was a flow from a few days ago right there coming in. But what I want to point out is a 35 flow. And a 35 flow is this guy right here, right? So if you notice, there's a bunch of this is all maybe not there. This bit here is from that 35 flow. The flow made it down around this far, and then a pahoehoe is what came and overran it and ran down most of the highway. So the flow itself was limited. It did come, looks like it might have come all the way to the edge there. Let me overlay the map there, so can't really see the difference between pahoehoe and on the map, but you can on the visual here. So see how far the doesn't quite make the whole flow to Hilo there. So we'll see if the flow changes to pahoehoe at some point and flows all the way down a mountain, then it's a whole other game as well. But that doesn't always happen. 84 did not happen. Not at least not very far from the vents. So you wait to see if that's something that occurs as well. Anything else, Dane?
Right. No, I think that gets us through the questions. I mean, there's always a little bit more. We'll try and answer a few more in chat. I think we're going on an hour and 40 now. Appreciate everybody that stuck with us. We will try and be with you again tomorrow and keep riding this out and see what the eruption brings and how long it's going to go.
Right on. Thanks, Dane, and thanks everyone for your support. Thanks for tuning in and getting the good info. Share it with your friends and neighbors. Make sure everyone knows what's going on, and what we really don't need is any fear or panic, right? And even if we have these possibilities on the horizon of a whole range of what could happen, we just want to be aware and prepared. That's why we're really doing this long term, is better preparedness and education for when a flow does come towards people, which thankfully is not this time. So until tomorrow, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha.